In this part, we're going to choose some particular instance in order to represent the graph of UC as function of time and of the charge Q as function of time. The three particular instances that we're going to choose are 0, tau, and 5 tau. At t0 equals 0, UC equals e exponential minus t over tau. So we substitute the time t by 0. Exponential 0 is 1, so equals e. As q equals c UC, so at t equals 0, UC equals e, so q equals c times e, so equals q max. So let's consider the graph of UC as function of time and of Q as function of time. At t0 equals 0, UC starts from E since the capacitor is fully charged, and then during the discharging phase starts from the maximum voltage E. And Q starts from a maximum charge C times E. At t equals tau, UC equals voltage E times exponential minus. Now the instant t is replaced by tau over tau. So equals E times exponential minus 1. Exponential minus 1 is 0.37 times E. So after a time tau, the capacitor reaches 37% from the maximum voltage E, or the voltage decreases for 63%. As Q equals C times UC, so we replace UC by 37% from E. So C times 37% from E, it means 37% from C times E. It means 37% from Q max. So after a time tau, UC is 37% from E, and Q is 37% from C times E, or from Q max. At t equals 5 tau, UC equals exponential, the voltage E, maximum voltage E times exponential minus t over tau equals the voltage E times exponential. The time t is replaced by 5 tau over tau. So equals E times exponential minus 5. Exponential minus 5 is approximately 0, so 0 volt. As Q equals C times UC, so after 5 tau, Q equals C times 0 volt equals 0 coulomb. So after 5 tau, the transient phase ends and the permanent phase starts, where the voltage is approximately equals to 0 and the charge is approximately equal to 0. So the graph of UC decreases exponentially like this, and the graph of Q also decreases exponentially like this. So here we have in figure 10 a clear representation, a clear graphical representation for the voltage UC as function of time, and as Q is proportional to UC, will have the same form starting from Q max till 0. And when t tends to the infinity, you see that is equal to e exponential minus t over tau. When this time tends to the infinity, exponential minus t over tau, it means exponential minus infinity tends to 0. So as this one tends to 0, UC also tends to 0. This is why the graph of UC as function of time tends to 0, where UG equals 0 is the asymptote of UC as function of time. Now, what about the tangent to the graph UC at t0 equals 0? It starts from E, since at t0 equals 0, the tangent is at this point. So this is the tangent to the graph you see as function of time. It cuts the asymptote UG equals 0 at a point t1. Let's verify that t1 equals tau. The slope of the tangent to UC at t0 equals 0 equals derivative of UC as function of time also at the instant t0 equals 0. During discharge, UC equals e exponential minus t over tau. So its derivative is e minus 1 over tau exponential minus t over tau. It means minus e over tau exponential minus t over tau. So this derivative is replaced in the slope of the tangent, so minus e over tau exponential minus t over tau, but at the instant t0 equals 0. Equals minus e over tau exponential 0. Why? Since the instant t is replaced by t0 equals 0 and exponential 0 is 1, so the slope equals minus e over tau. Graphically, the slope of the tangent to the curve you see at t0 equals 0 equals minus tangent theta. Why minus? Since the tangent in this case is a decreasing straight line, so it is of negative slope. Okay? Where is the angle theta? It's between the tangent and the time axis. This is theta. Okay? Tangent theta equals opposite in this triangle. Sorry. This is theta in this triangle. The opposite to theta is this side, so it is E. The adjacent to theta is this side, so it is T1. So equals minus E over T1. So the slope equals minus E over tau and minus E over T1. Then minus E over tau equals minus E over T1. Thus, T1 equals tau. What do we conclude? The tangent to the graph you see as function of time at t0 equals 0 cuts the time axis with the point t1 or with the abscissa t1 equals tau.